Children, look at the sixth question carefully. It was very clear that this is from semiconductor chapter. Why? Because here gate is mentioned, gate, logic gate. Okay. So this is from semiconductors. We are studying now logic gates from semiconductors only. Now observe carefully what is happening. The bulb is there on the right side. Switches are there on the left side. Switches are there on the left side. Okay. So what happens is that if A is opened, if switch A opened, then the current through it is 0. Switch A opened. Okay. Opened in the sense you have to say 0. A is 0. Then current through it is 0. So then what happens to the other side? So if there is no current through A, then current through B flows. If there is no current through A, so circuit diagram is like this. Okay. Like this. So here A has been opened. A opened. A has been opened. So the current through this one is nothing. There is no current. Since it is open, current cannot flow through the open path. So here there is no current. I equal to 0. But what are the current that is coming here? So if one path is open, it has to move to other path, right? So it has to move to this bulb path. So now what happens? This bulb will glow brighter. This bulb grows brighter. So if switch A is open, bulb glows. So you are getting output as 1. You are getting output as 1. Similarly, if switch B opened in the sense logic gate, what we have to say, take this number here, 0. So then also, if B is open, what happens? Still the current through this switch is 0. So now also the bulb glows. If switch B is open, what happens? No doubt, no current flows through it. Then current has to take other path. Other path is that bulb path. Understand? Other path is nothing but bulb path. Why? Because this is nothing but current is splitting in two different ways. Look, this is one way and this is other way. In this way, you are having a bulb. Okay? But in other way, switch has been opened. So what happens is that if switch is open, the current through it is 0. No current here. So the total current, whatever you are getting here, it flows like this. So it goes like this. So what happens? Now this bulb again glows. So if switch A opened or B opened, what happens? The bulb will glow. That you have to remember. Yeah, bulb glowing in the sense nothing but 1 given by the logic gate number. Logic number 1. Okay. Now, if both the switches are opened, then what happens? Again same thing happens. If both the switches are opened, then no current flows through the switch. So the total current flows through the bulb. Again the bulb glows. So now I'll take it as a truth table. So A is one switch, B is other switch. Okay. Like this. Like this. So output is bulb glows. So let me say this is output. Okay. So in the first case, what we are mentioning here is that both switches are opened. So opened in the sense we have to take it as 0 or 1. We have to take it as 0 or 1. Think. Open in the sense useless. So take it as 0. Take it as 0 because open means no current, right? So 0, 0. So what happens here? Current through switch is 0 but not through the bulb because switch is in other path and bulb is in other path. So the switch path no current but bulb path they are having a current. So bulb will glow. Bulb will glow. Okay, brighter it will glow. So output is 1. Now, if A is open in the sense 0. B is closed, switch B is closed, assume. So then also what happens? If A is open, I told you that the bulb glows. Now, if B is open and A is closed, so B is open, then also what happens? Bulb is glowing, so output is 1, like this. So final one, if both the switches are closed, if both the switches are closed, what happens? That we have to see. So if both the switches are closed, so current has to flow through the switch. But your doubt is that, sir, here current is splitting, no? So some current flows through the switch and some current flows through the bulb. So bulb has to glow, no? May not be brighter. It has to glow, no? That is your question. But children, what I mean to say is that switches offers a low resistance path. Low, very, very low, minor. Better to say short circuit. So ideally it is 0. So no resistance, 0 resistance. So total current has to take the switch path only. So if there is short circuit, the current has to flow through switch only, because switch is short circuited, bulb is not circuited. Then what happens? There is no current left over here to flow through the bulb. It means that when both the switches are closed, A and B closed, so you have to put 1. Then total current flows through the switch but not through the bulb, because there is no current left over there to flow through the bulb. Why? Switches are offering low resistance. We could call it as a short circuit. Okay. So there is no current left over to flow through the bulb path. So what happens if no current? The bulb also doesn't glow. So now I have to take it as a 0 for the bulb. So like this I am forming a truth table. Okay. Now here I'll write, if switch A and B closed, it offers low resistance path. That is, ideally resistance will be equal to 0. That is short circuit. Hence, total current flows through switch but not through bulb. Flows through switch but not through bulb. Therefore, bulb does not glow. Does not glow. Okay. So like this I formed truth table. Now my dear children, as per the given options, we have to check it whether it is OR gate or NAND gate or NOR gate or AND gate. Check it carefully, this truth table, where it matters. So we have studied that for NAND gate, we have studied that A and B are inputs. Its output is given by A dot B whole bar. This is what is given. Okay. So look at this. The truth table, I feel that A dot B bar is matching here. A dot B bar is matching here. Why? A dot B is 0 into 0 is 0. Okay. So if I write one more thing, AB, what I'll get? 0 into 0, I'll get it as 0. 0 into 1, again I'll get it as 0. 1 into 0, I'll get it as 0. 1 into 1, I'll get it as 1. Like this. Okay. Now, AB bar. What happens? Bar in the sense we have to take the reverse of that one. Complement. So 0 bar is 1, 0 bar is 1, 0 bar is 1 and 1 bar is 0. So like this, I will get the truth table. So this truth table is meant for what? NAND gate. So these options, whatever I got here, these are matching with what? Which gate? NAND gate. So here, option 3 is our right choice. Option 2 is our right choice. Option 2, that is NAND gate, is our right choice. With this, we have done our 6th question. Now we move on to the next one.